Okay, thank you, Ray.
Great.
Hello, everyone. My name is Lala Septem Riza. I'm a PhD student in University of Granada. Today, I'm going to talk about RoughSet, which is a classification tool based on RoughSet and fuzzy RoughSet in R. It was created by collaboration between Department of Computer Science and Artificial Intelligence, University of Granada, and Institute of Mathematics, University of Warsaw. And this is a list of the author. So we have Andre, Christoph, Chris, and my supervisors, Paco, Dominix, and Jose Manuel Benitez. This is my outline for today. So I'm going to talk about RoughSet theory and fuzzy RoughSet theory, and then I will continue to introduce the RoughSet package and the implementation of the algorithms, and then I will show you how to use the package and some demos, and then we can conclude the presentation. So, introduction to RoughSet theory. RoughSet theory was proposed by Pollack as an extension of classical set theory for dealing with imprecision knowledge. So the main idea of RoughSet theory is indivisibility relation, which is a relation to evaluate to what extent two objects are identical or similar. Using the relation, we can construct lower approximation and upper approximation. Lower approximation consists of all instances which truly belong to the concept, while upper approximation contain all instances which possibly belong to the concept. I would like to say that one benefit of RoughSet theory is that we do not need to supply any additional parameter to extract information. Okay, now basic concept of RoughSet theory. In RoughSet theory, a data set is represented in table. We call it information system. So information system contains a U, a non-empty set of objects, and a finite non-empty set of attributes. And the special kind of information system is a decision system. Decision system is a kind of information system that contains the decision attribute, or we can call the output attribute. And the main idea of RoughSet, as I said before, that indivisibility relation. So, given information system for any V subset A, the equivalent relation RB is defined by this equation. So if object X and Y in relation RB, then X and Y have exactly the same value for the attribute in B. And we have a notation like this for the equivalent classes. That's it, the relation. And now approximation, about approximation. So given B subset A, X subset U can be approximated using information in B by constructing lower and upper approximation. So we have here the first one is lower approximation and the second one is upper approximation. So you can see that basically RoughSet theory can be used for feature selection. Why? Because we just consider B instead of A. A is all conditional attributes, but we can approximate X. So that's why RoughSet theory usually used for feature selection. And then we have a positive region. Positive region is the set of objects in U that can be certainly classified using conditional attributes. So positive region is union of lower approximation. And then we have a boundary region, contains a set of objects that can be possibly but not certainly classified using attribute B. So boundary region is the difference between union of upper approximation and the union of lower approximation. You can see here that the green area is the boundary region, and then here we have a positive region, and the red line is our data set. So in RoughSet theory, thickness is represented by boundary region. If you know about a fuzzy set, thickness is represented by degree of membership function. So that's different between RoughSet theory and fuzzy set. Now talking about a fuzzy RoughSet theory. Fuzzy rough set theory is a combination between fuzzy set and rough set theory. In order to calculate indivisibility relation, we can define a kind of indivisibility relation. We call it the fuzzy tolerant relation RB. So, for example, here we have the small r, A is a fuzzy similarity equation. So we have, for example, like this, and then the fuzzy tolerant relation is actually an aggregation of fuzzy similarity equation over all attributes in B. In this case, we are using T-norm for aggregation operator. Then regarding the approximation, for example, Radikoska and Kere define lower and upper approximation as follows. So the first one is lower approximation and the second one is upper approximation. So you can see that for fuzzy rough set theory, we have to define type of relation, fuzzy similarity equation, and implicator and T-norm aggregation. So we need to know about this parameter because when we are using fuzzy rough set theory, we have to define these algorithms. And a benefit of fuzzy rough set theory is that we can analyze data without performing discretization. If you see in rough set theory, we have to do discretization if we have continuous values in our data. Now, I'd like to introduce the RoughSet package. So, RoughSet package is an R package that try to integrate implementation of algorithm based on RoughSet theory and fuzzy RoughSet theory. And then I would like to inform you that our paper about RoughSet package has been accepted in Information Science Journal. Then we believe that the RoughSet package can be used for researcher, academic purpose, and practitioners. Why? Because researcher can build a new model by defining custom function as parameter, and for practitioners can perform data analysis. But in this presentation, I just focus on the second one, so I just show you how to use RoughSet package to perform data analysis. RoughSet package contain over 40 functions that implements basic concept, missing value completion, discretization, feature selection, instance selection, rule induction, and nearest neighbor based classifier. It's available now for version 1.1 on CRAN. You can download from this link. Okay, then we continue to implementation of algorithm. So because we have so many functions in RoughSet package, so we have to manage the name of function with some convention. So function names in RoughSet contain three parts: prefix, suffix, and middle names. For prefix, we have a BC, is used for basic concept, and we have a D for discretization, FS for feature selection, IS instance selection, and then rule induction, nearest neighbor based classifier, and MV for missing value completion, SF for supporting function, and X for auxiliary function. In suffix, we have three types. IST is for RoughSet theory, FRST for fuzzy RoughSet theory, and none. None means that the function can be used for both theories. And we have middle names, which is the actual function name. So for example here, we have fs.quickredux.rst. So this function can be used for feature selection that implements the quick redux algorithm based on RoughSet theory. This is a big picture showing all features in the RoughSet package. So first we have a basic concept. We already considered indivisibility relation, lower and upper approximation, positive region, and discriminability matrix. And for missing value completion, we have 5 algorithms that based on the close fit and most common and deletion approach. And we have discretization. So we have a dynamic discretization, static, global, local, unsupervised, and supervised discretization. For instance selection, we have implementation algorithm based on prototype selection and positive region. For feature selection, we provide many algorithms actually, but according to the output of function, we can classify them into 3 groups. So we can classify according to a set of redux. So with all redux, we can generate all redux, and we can produce single redux. Also, we can produce a super redux. And rule induction, we have 2 kind of rule induction here: exhaustive rule and minimum rules. And finally, we have nearest neighbor based classifier. We have 3 algorithms based on positive region, membership approach, and lower and upper approximation. So let's take a look implementation of basic concept. As I said before, that we provide 4 main basic concept of RoughSet theory and fuzzy RoughSet theory. In indivisibility relation, we have equivalent relation for RoughSet theory, and we have crisp, tolerant, transitive kernel, transitive closure, and custom function for fuzzy RoughSet theory. In lower and upper approximation, we have Paul's standard for RoughSet theory, and we have implicator norm, thickly quantified RoughSet, order weighted average, robust fuzzy RoughSet, then fuzzy variable precision RoughSet, and etc. for implementing fuzzy RoughSet theory. And also we have positive region and degree dependency and discernibility matrix. Especially for fuzzy RoughSet theory, we can define a custom function on type of lower approximation, type aggregation, t-norm, and t-implicator. Okay, continue to implementation of missing value completion. You know that missing value completion is a process to deal with missing value. We provide 5 algorithms here. So for example, we have MP deletion cases for implementing deleting instances, and we have algorithm based on the most common value and the global closed fit and the concept closed fit. And also we provide the wrapper function, which is MP missing value completion. So this is the signature of the wrapper function. So we have 2 parameters here: decision table, which is our data set, and type method is one of the algorithm. And then implementation of discretization. Discretization is a process for converting real value to nominal ones. We provide also 5 algorithms here. So you can see here we have a discretization based on maximal discernibility algorithm. Also we have local strategy, global maximum, and for unsupervised discretization we have quantile and equal interval size. And we provide a wrapper function. This is signature of discretization, ISD. So we need to supply the decision table and type of method, the same as missing value completion, I think. Then implementation of feature selection. In RoughSet theory, feature selection is a process of finding subset of attributes which give the same quality as the complete feature set. We actually provide many algorithms, but I just show you 5 of them. So we have feature selection based on quick reduct based on RoughSet theory, and also quick reduct based on fuzzy RoughSet theory, and so on. We have other, and as I said before that we can classify into 3 groups. So we have 3 wrapper function here. First, we have a signature of redux computation is used for computing single redux, and feature subset computation is used for feature subset, and also we have signature of all redux here, which is a wrapper function, the wrapper function for computing all redux. Implementation of instance selection. Instance selection is a process to remove or replace noisy or inconsistent instances from training dataset. So in RoughSet theory, actually it's simple way to get instance selection, because you know that the boundary region represent a thickness. So if you want to remove or replace noise, so you just delete the object included in boundary region. So that's the simple way. Or also you can consider the positive region. In RoughSet package we have 2 different algorithms here: freeze is the algorithm based on fuzzy rough instance selection, and also we have FRPS is fuzzy rough prototype selection. For example, here this is the signature of fuzzy rough prototype selection, so we need to supply parameter decision table and type of alpha. This is, I think, the default value of type of alpha. Actually, we provide 4 type of alpha, so you can choose one of them. Then implementation of rule induction. Rule induction is approaches used to extract knowledge in if-then rule. As I said before, that we have 3 algorithms. One algorithm based on RoughSets theory, which is indivisibility based rule, and we have 2 algorithms based on fuzzy RoughSets theory. We have hybrid FS or quick rule algorithm, and also we have GFRS, generalized fuzzy RoughSets rule induction. For example, here this is signature of indivisibility based rule. We have 2 parameters here. Decision table, which is our data sets, and feature set. Feature set is the output of feature selection method. So before we calling this function, we have to execute the feature selection function. And then after we get decision rules, so then we want to predict a new data set, we just call a predict function, which is st function. So it's common in R. So it's just object and new data parameter. And then the last feature, nearest neighbor based classifier, which is approach to combine KNN with lower and upper approximation. We have 3 algorithms here: FRNN, fuzzy rough nearest neighbors, and FRNNO, fuzzy rough on-receive nearest neighbors, and POSNN, positive region based on fuzzy rough nearest neighbor. And this is the example of FRNN. So in this function, we need to supply decision table, which is our training data set. New table is our testing data set, and also control parameter. In control parameter, we have to define values of type of lower approximation. K is the number of nearest neighbor, and type aggregation, type relation, and the implicator. As I said before, that most of methods are based on fuzzy RoughSets theory. We have to define type of lower approximation, type aggregation, relation, and implicator. And it should be noted that all value in our data must be numeric. So when we are using this function, we have to make sure that our data is in numeric. So if you have a string, for example, you have to convert into numeric first. Then, okay, now I will show you how to use our package. So in order to analyze data using RoughSets, we have to consider the following steps. First, we need to prepare our data set, of course, and then this is the most important step. We have to convert our data to the standard format, which is decision table. I will tell you about this later on, and then if you want, you can perform data preprocessing, for example, missing value completion, discretization, and so on. And then you can generate learning model and predict new data using rule-based classifier and nearest neighbor-based classifier. So first, data preparation. Should be noted that the training and testing data must be in data frame. And if you have a missing value, you have to define not available and A. So here we have data x1 in data frame, and you can see that we have a 4 column here, and we have some missing values, this one, and this one. So then we can define the name of attribute. For example, we have temperature, headache, nausea, and flu. Then we need to construct decision table before calling any function in RoughSets. What is decision table? Decision table is a class used to express the decision system and information system. We already know about this terminology. And decision table contains 3 attributes. Nominal attributes is a list of Boolean value for representing type of attribute, whether they are nominal or not. And this description attribute, it composed of 2 parts, name of attribute and range of data. and the decision attribute is a position of decision attribute or position of the output attribute. If you have a testing data set, so you don't have it. You don't have a decision attribute, so you just set no or just leave it. And how do we construct decision table? We have two ways here. So if you have a data set in data frame in your R environment, you just call SF as decision table. But if you have a data set in a file, for example txt.etc., you need to call read decision table. And then after getting decision table, you can do this data analysis using RoughSets. So this is a signature of S decision table. So we have data set and then decision attribute, position our decision attribute, and we need to define index nominal. And this is for read decision table. We have file name, so we have to define the name of our file, and then decision attribute and index nominal. And also we have other parameter here. Actually, this parameter is from read table parameter, so you can take a look read table manual. I think the most important parameter here is call names and expiration symbol. And okay, so for example, using the previous data, let's say the second, third, fourth attribute are nominal, and the fourth attribute is the decision one, decision attribute. So we need to execute this command. So we just call as decision table. So data x1, we have data set as data set, and decision attribute is 4, and index nominal 2, 3, and 4. Then we got text table x1. Then we have note here that if we do not set index nominal, so RoughSets will define it according to the data type. So if you have string values, RoughSets will recognize as nominal values. Then you can print the nominal attribute. So we have false, true, true. And for description attribute, because we have a missing value in temperature, so we have not available for minimum and maximum. And also on headaches attribute, we have no, yes, not available, nausea as well, and flu, no, yes. And you can take a look that the position attribute is 4. Okay, let's continue to data preprocessing step. Now you know that RoughSets provides 4 features for data preprocessing, which are missing value completion method, discretization, feature selection, and instance selection. But you have to remember that all methods included in data preprocessing do not generate a new decision table. So for example here, missing value completion method will produce completion value instead of a decision table. Discretization method will produce cut values. We have decision reduct for feature selection. Index of selected object is from instance selection method. So in order to generate a new decision table, we have to call this function SF apply dictable. So this is a signature of SF apply dictable. So we have 3 parameters here: decision table, object is output of our method, and the control parameter. So for example, missing value completion, we already have dictable x1 from previous example. And for example, I'm using type of method deletion cases. So we just call a wrapper function, the wrapper function of missing value completion, mv missing value completion. Then we call object mv. Then we need to generate a new decision table using this function, apply dictable. So like this, and you can print new dictable. So we got this table. So you can see that we don't have missing values anymore. And also you can print attribute. So we have the same nominal attribute, but in description attribute we have minimum and maximum values for temperature attribute, and headache just have no yes, nausea, no yes, flu, no yes, and It's still the same. Position of decision attribute is 4. Okay, and then the next example, you can do discretization. For example, here I'm using local disk matrix for discretization, and then I execute the wrapper function of discretization, the discretization.ist. Then we got object cut value, and then we need to generate new decision table by calling this function. Then you can see here that we got a new decision table. So the values of temperature attribute are represented in range of data, not in label actually. So, but you can see that actually we have two labels, no? This one and this one. And you can check again by print attribute of nominal attribute. So we have all true here now. So they are nominal values. Okay, let's continue for generating learning model. As I said before that we have two models based on RoughSet and fuzzy RoughSet. In RoughSet we have indivisibility based rule, and in fuzzy RoughSet theory we have hybrid FS and GFRS. I'd like to say that in this feature we have to consider two steps. First, we need to generate learning model. So in this case we call it a decision rule, and then if you want to predict values, you just call a predict function. And for nearest neighbor based classifier, we have three algorithms here: FINNO, FINN, and POSNN. But in this case, we just call the function. We just need to supply the training dataset and testing dataset at the same time. So then we get the predictive value. So we just call this function only. So we don't need to generate a learning model in this case. Okay, finally, I will show you the demo. In this demo, I'm using wine dataset. You know that wine dataset contains 178 instances with 14 attributes, where all conditional attributes have continuous values. So for example, I have three scenarios here. First, rule-based classifier based on RoughSet theory. And because we have a continuous values in our data, in wine dataset, so we need to do discretization first, and then we continue to feature selection and rule induction. After getting a decision rule, then we call a predict function. The second scenario, rule-based classifier based on fuzzy RoughSet theory. For example, it's just example, just I want to show you how to use all features in RoughSet. So first, for example, I will do feature selection and then instance selection, and then I will generate a decision rule by using rule induction, and then I will call a predict function. The last scenario, I will use two methods based on nearest neighbor based classifiers, which are FINNO and FINN, to predict the values. Okay, maybe let's go to my art studio. So maybe I need to remove first to clean. Okay, so first step, I need to prepare my data. So because we already include wine dataset, so I just load the data and we call it a dataset. Then I need to shuffle the data. Then I need to split the data into training and testing dataset. For example, 80% for training and 20% for testing. Okay, and at the same time I construct the decision table for training. We call it wine TRA, and for testing we call it wine TST. Okay, that's it. We are ready to go to scenario 1, but maybe we can check our data. Okay, good. And then for testing, okay, we have it. We go to scenario 1. First, we need to do discretization. For example, in this case, I'm using global discernibility. and then you can print cut values. So the output of cut values is a class, which is a discretization class, and you can see here we have some attributes, but the most important attribute is cut values. So we have a cut value for alcohol and etc. And then you can do feature selection now. I'm sorry. Okay, then we need to generate a new decision table. For training, we call it the TRA, and for testing, we call it the TST. And also you can check the nominal attributes. So you can see here that we got all true for nominal attributes, so already discretized. And then you can do feature selection. For example, here I'm using quick reduct based on RoughSet theory to get a redux. And I'm using a wrapper function, the feature subset computation. Okay, we call it. And then we can print the redux. So we have here feature subset class and some description, and this is the redux attribute. So we have now 1, 2, 3, 4, 5, 6. So we have 6 attributes now. And then if you want, you can generate new decision table. And then you can print the decision table after feature selection. So we have 7 attributes, and then we can do rule induction. Okay, we got it. And if you want to take a look at our rules, so we have 142 rules here. So you can see that we have if then rule. So if alcohol is in this range, blah blah blah, then class is 2. And this is the value for degree to representing degree of this rule. And we are ready to predict new data. That's it. That's it for the scenario 1. We can check the predicted values. So okay, good. And let's go to scenario 2. So in this scenario, for example, I'm using quick reduct based on fuzzy RoughSet, and you can see that I'm using original datasets, so before discretization. Then we can print redux. Okay, so we got 1, 2, 3, 4, 5 attributes in this case. And then I need to generate new decision table for training and testing. We call it wine training after feature selection and wine testing after feature selection. After that, we can do instance selection. For example, I'm using the function FRIS, freeze, based on freeze algorithms. And I define control parameter, for example, threshold tau is 0.3 and alpha is 1. Okay, we got index. Then I generate a new decision table of training data sets. So now we got one training after instance selection. You can compare with the previous data set with row. So I want to know the number of our data sets. So we have 90 objects. You can compare with previous wine TRA after feature selection. Now we have we have 142. So you know that some object already deleted. Then you can do rule induction based on fuzzy RoughSet. For example, I'm using hybrid FS here, so I need to supply wine training after instance selection, and then control parameter. In control parameter, for example, I assign a type of aggregation T-norm Lukasevich, type relation tolerance with equation 3, and type of implicator I'm using cleaner DNS. Let's see. Okay, done. And then we can summarize. can type summary to get the rules. So you can see that we have 90 rules. If flavonoids is around something, blah blah blah, and then class is 2. That's our decision rule for the second scenario. Then we are ready to predict new data. That's it. Okay, done. Let's take a look. Oh, sorry. Habits. So we got it. And for the last scenario, okay, in this scenario I consider 2 algorithms. So first FINNO, so I need to define the control parameter. For example, M is 2 and type membership is gradual. So we just call the function and then we got the result. So in this function we need to supply training dataset. This is our training dataset. I choose training dataset after feature selection. Actually you can choose the original training dataset, and our testing dataset is also after feature selection because I want to because we need to have the same attribute. And then the second method I'm using FINN. So for example, I'm using type of lower approximation implicator t-norm, and case the number of nearest neighbor I set 20, and type of aggregation I set t-norm Lukasevich. For type relation tolerance equation 1, and type implicator I'm using Lukasevich. So let's try. Okay, we got it. So done, and then the last thing, we need to compare all results. So this is the real value we have, and we calculate the error. Okay, that's it. So you can see that we have the percentage error for the first scenario, 8 point something, and the same as the second scenario. But for the for method FINNO we have 2 point something and the same as FINN. So that's our demo. Let's go to our presentation.
Great, Lala. Thank you. That was a great presentation. Anything else you want to comment on?
Yeah, this is the final presentation. Yeah, so we can conclude that RoughSet provides a basic concept: missing value completion, discretization, feature selection, set selection rule induction, and prediction based on RoughSet theory. And in the future, we will attempt to extend our software to deal with imbalance classification and big data. That's it. Thank you for listening. Back to you, Ray.
Great. Thank you, Lala. Great presentation. So what we're going to do now is go into a question and answer period. So if you have a question for Lala, go ahead and send it in through the GoToWebinar chat window in the questions pane. Just type it in and hit the send button, and then I'll be able to see your question, and I'll just ask Lala verbally. So I'm going to start off with some questions here. Lala, why do we have to convert our data from a frame to a decision table?
Yeah, because in RoughSet theory and fuzzy RoughSet theory, the real values and nominal values are computed in different way. So the function need to recognize which attribute is a real value and a continuous one. So that's why we need to convert into decision table. That's it.
Sure.
Yeah.
Okay, next question. Do we always perform discretization when using methods based on RoughSet theory?
Yes, yes. If we have continuous values, and if you want to perform some methods based on RoughSet theory, yes, you have to do discretization first. But if you perform methods based on fuzzy RoughSet theory, it's not necessary to do that.
Sure. Okay. Can we use the RoughSets package for data containing mixed values, for example, nominal and continuous?
Yes, of course. As I said from the previous example, so maybe you can see here.
Sure.
Okay, so you can see that we have a mixed value here. So for the first column, we have real values, and the rest is nominal values. So you can mix the value.
Sure.
Yeah.
Okay. So I have another question here. How many discretization methods are in the package?
Sorry, could you repeat that?
Sure. How many discretization methods are in the package?
The package. So yeah, maybe you can take a look at this one. So we provide 5 algorithms here.
5
So
different.
for example, yeah.
Okay,
Yeah,
and
5
they're all
different
listed right there.
algorithms. So yeah.
Sure.
And also we provide wrapper function. So if you don't care about this function, you just call the wrapper function, just supply the algorithm, the parameter. Sorry. So that's all. So yeah.
Yeah. So the person just wanted to know the method. So you have maximal discernibility, a local strategy,
yeah, local strategy, and
global max, quantile, and equal interval. So
yeah. For
okay, there you go.
Yeah, for unsupervised discretization, we have quantiles and equal interval size. Yeah.
Sure. Well, great. So here's another question: will the k nearest neighbors algorithm give better results?
Sorry, which algorithm?
K nearest neighbor.
Okay, nearest neighbor. Okay, yeah.
Yeah, will that give better results?
I don't know actually. Maybe it depends on our problem, no? So that's why we provide many algorithms. So you can just try all of them actually.
Sure.
So and you can do fitting model, and then you can choose the best one.
Sure.
Yeah.
Okay, sounds good. I have another question here. Can we download your paper online?
For recently, we are still waiting for in press, and so we're still in publish. So
it hasn't been published yet.
Yeah.
Okay. After it gets published, is there a certain website?
Maybe yeah. You can download it.
Okay. So they could basically just Google the name of your paper and. What is the title of your paper?
Actually, I also include some introduction about RoughSet and fuzzy RoughSet in the manual, so you can take a look at the manual.
Oh, and the manual for the on CRAN.
Maybe I can show you. I think we have time, no?
Yeah, we have time.
Okay. So you can see that we have introduction of RoughSet and introduction to fuzzy RoughSet. So you can take a look and you can read. You can study them because maybe
Yeah, that's just on CRAN, right?
Yeah.
Okay. And Lala, someone asks, do you have a home page, like a personal website where you upload things?
Yeah, I don't have it. I'm sorry.
Okay.
But maybe you can take a look.
Well, what we can do is you can. Go ahead.
You can take a look. Yeah. You can take a look this link, no? You can go this link. This is
there it is.
Website of our research group. So.
Yeah, there it is. So you can just go to the manual.
I provide many examples in this website. So.
Sure.
Yeah.
Okay. So that's on what page of the page number 1 of the manual?
Yeah.
Okay. Okay. So looks like we got that. And then can we use RoughSets for regression?
Yeah, actually, yes, you can. Especially for method based on fuzzy RoughSet theory. So, for example, I can show you the manual. For example, I am using hybrid FS. So which one? Hybrid rule induction. So this one. Okay. So you can see that I provide the example for regression here. This is for regression problem, and this is for classification problem. So actually yes, but in current version we focus on the classification. So that's why I say that RoughSets is for classification tool. But actually you can do it for regression problem as well.
Sure. So we have a question coming in regarding the manual. So if somebody wants to download this manual, can you show them on CRAN where to go?
Yeah.
Because I think some people are new to R and they don't have a background with CRAN.
Yeah, actually you can search from Google. I also follow.
Yeah, you can just basically Google RoughSets, right?
Yeah, in CRAN.
Yeah, just Google RoughSets and CRAN like Lala is doing now.
And then you go to this one. Okay. So
Yeah.
you can download.
Yeah, so for those of you who don't know, CRAN stands for Comprehensive R Archive Network.
Yeah.
Very good. So that's just the regular page.
1.1. Huh? Okay. Sorry.
Sure.
Sorry there.
Oh yeah, I was just saying that that's the standard CRAN page for RoughSets.
Okay. Yeah.
Yeah. Okay. Very good. So if anybody has any more questions, we have another one about the .r file. So what we can do if Lala is interested is we can put a link to the code in the video page that we're going to send out to the audience.
Yeah, you can do it.
And then you can download the code from there. Yeah. So we should have that up within the next 7 days from now.
Yeah.
And just give us some time for that.
Into the website so you can do that.
Yeah, that would be a good idea. Just integrated the .r file into the website, and then they can play with your code.
Yeah,
okay.
Of course, yeah.
Okay, so anybody else, if you have a question, go ahead and ask it. And it looks like somebody tried the URL on page 1 and it was not working. Could you try clicking that URL, Lala, just to see if it's still working?
Which one?
The link on page 1 of the manual. There is a URL.
Our website. Okay.
Yeah, let's see if it works for you. Yeah, just try clicking that link.
Oh, okay. Maybe I need to take a look at, or maybe you can just type. I don't know. Actually, you can go to the RoughSets group. Sorry.
So that's kill.es.
I don't know what's happened. Okay, I will take a look the link. So.
Okay, it may be working.
Yeah, maybe working, but there is problem in the server, so that's
sure.
Yeah.
Okay, well, we'll take a look at that later. So, all right, any more questions in the audience? Go ahead and send them out, and I'll leave another maybe 15 seconds. If we don't get a question, then Lala can give his closing remarks. So, yeah, it looks like no more questions are coming in, Lala. So go ahead and you can give your closing remarks now, and then we can end the webinar.
Okay, thank you for coming today. And if you any question or any problem, you just contact us. Maybe you can contact Christoph as maintainer, so I will answer it. That's
Great.
It, maybe.
Well, thank you, Lala. That was a very interesting webinar.
Thank you.
Yeah, we got a lot of positive feedback from the audience saying they liked the webinar, and most people stayed the entire time. So we had a very few people leave the webinar, so that means it was very exciting. So
Okay,
that's good. Yeah, good presentation. So, all right, everybody, we'll have the video up on the internet within about 7 days if you want to show your friends. And I'd like to thank everybody for coming today. We're going to go ahead and shut down the webinar. Everybody have a good day or evening wherever you are. Take care.